What up, Sci fam? It's your boy Nickel, and today we're going to learn about limitations of science experiments, or limitations of things that could cause changes or issues in science experiments. So go ahead and title your page Limitations. We're going to define what a limitation is, and then we're going to look at 3 different examples of types of things that can limit the quality of a science experiment. We'll look at sample size, a control group, and then also bias. All right, let's get started then. This title is Limitations. So what are limitations? Well, essentially, they're aspects of a scientific investigation or experiment that reduce the accuracy of the results. So remember that data that we were talking about on the last video or in a couple videos ago? Well, there are certain aspects of investigations that actually, if certain things happen, it actually reduces the accuracy of those results. And so as scientists, as really good scientists, what's important is that as we do an experiment, we're thinking about the limitations. We're thinking about what are some things that maybe could go wrong or did go wrong that are going to reduce the quality of your data. So we want to try to prevent that, and we want to try to plan ahead so we don't have very many limitations. So we don't end up having data that's not very accurate. So how do we do that? Well, one thing that's really important is something that is known as sample size. Sample size. And sample size is defined as the number of trials, or just of test subjects that are in an investigation or experiment. So the sample size is the number of trials or test subjects in an investigation. Now, as an example of this, let's say that I went to school and I asked one student, what is your favorite type of soda? And they said, oh, that's easy, it's Dr. Pepper. And then I went off and I was talking to my friends and I told them all teenagers love Dr. Pepper. It's their favorite soda. I asked them, trust me, I know. Well, guess what? I did ask them, but my sample size was only one student. So therefore my results that I'm getting, my conclusion is not very accurate because my sample size was really, really small. Now let's say I went and asked the same question, but I was able to ask 1,000 teenagers about what their favorite soda was, and I found out that their favorite soda was actually Coca-Cola. Well, now that I have 1,000 people's information, that is a more accurate number. But there's way more than 1,000 teenagers in the United States. So in order to increase my accuracy even more, I would maybe want to survey more students. And the more students I survey, the stronger and the stronger my results become, because I've asked so many people that my results become more and more reliable. When I only ask one person, I don't have very reliable results. Even if I asked 10 people, my results might not be very good. If there's tons of teenagers in the United States, asking 10 is not enough. So sample size is just the number of trials or the number of test subjects that you use to get your information in an investigation. And basically what we need to summarize here is that a bigger sample size, the more people you ask or the more times you try and you repeat your information or you repeat your experiment, the more times it happens, the bigger sample size is going to actually increase the reliability of our data. So we want to do as many trials as possible. The more trials, the better. The next thing that could limit or provide a limitation in your experiment is something that we're going to call, or that is called, control groups, or a control group. And a control group is a group or just a trial in your experiment, in the investigation or experiment, that is conducted in what we're going to call, I'm going to put quotes around it, normal conditions. Now, what does that mean? Well, what this means here is, let's say, for example, that I told, let's say I have 4 class periods. I have first period, second period, third period, and fourth period. And let's say I have a hypothesis that if I tell students that they're going to get ice cream, that they'll score better on their test. Well, since I have 4 different classes, that's like having 4 different trials. So if I went through and if I told every class that I would give them ice cream, I should see that, at least if I'm correct, that the test scores increase in first period and second period and third period and fourth period. Because if it's true, then it should happen all over in every single class. Now, one thing that's hard to tell is maybe I tell my students, yeah, I'll give you ice cream if your test score goes up. But what if I maybe didn't even say that day? Maybe it was just a really good day. And maybe already the students coming in first period were already going to score better. And the students in second period were already going to score better. And the students in third period were already going to score better. And same thing in fourth, that they would already score better. Maybe the information was easier than I expected. And so maybe it wasn't the ice cream. Maybe there was another variable in there that actually caused their scores to go up. So what does a control group do? Well, a control group means that, let's say, I'm going to use purple here. Let's say in first period, I give them ice cream and their scores go up. And in second period, I give them ice cream and their scores go up. But third period, sorry folks, third period, I'm not going to give you ice cream. I'm not even going to tell you about the experiment, because what I need to do is I need to provide normal conditions, because I need to see if the ice cream in first period and second period is truly the thing that caused the scores to go up. Now in third period, we'll say that their scores just stayed normal. They didn't change. They didn't go up. They didn't go down. Everyone scored about the same as they normally would. And then in fourth period, I told them, all right, I'll give you ice cream if your scores go up. And you know what? Their scores go up. Now, using this data, since I did not use ice cream and the third period had normal conditions, I can now prove that ice cream is the reason the scores went up in first, second, and fourth period. If I did the same thing in first period and I said, yeah, you can have ice cream and their scores go up. Second period, I say, yeah, you have ice cream, and the scores go up. In third period, I didn't tell them anything, but hey, their scores went up. In fourth period, I said, hey, I'll give you ice cream, and their scores went up. Well, since the scores went up in all cases, it might not have been the ice cream that actually caused that. That's why it's so important that we end up using the normal conditions on one of our trial groups, so that we know that the thing that we're changing, the independent variable, is the thing that affects the results. So when we do have a control group, what that means is that we're not doing any type of special treatment for one of the groups. Like, that group doesn't get ice cream. They don't get the special treatment. Or when they test some certain types of drugs, they'll give some people what's called a placebo. They'll give them just a fake pill and tell them, hey, this is going to cure your cold. And you know what? Sometimes that works because it's more in their head than it is in the medicine. And that's an important thing for medicine companies to know, because we want to make sure that when you buy medicine from the store, that it's going to do what it says. And it's not just something in your head, but the medicine is the thing that actually causes someone to get better. So when we use a control group, if the people in the control group, the people who get the special, that get the normal, like, regular pill with nothing special in it, if they don't get better, but the people that get the real pill get better, then we know that the real pill actually is the reason they got better. So the control group gets no special treatment, or we could also say there's no use of the independent variable. Because remember, the independent variable is the thing that I, the scientist, will change. It's what we're changing in a group. Well, the independent variable, we're not going to change it in one group to prove that when we change it in the other groups, it's that thing that caused the difference in our results. So a control group, if we add a control group to our experiment, along with our other groups that are the test groups, if we add a control group, then it's actually going to increase our reliability, because we can compare our test subjects or our test groups to our control group. And the last thing that we're going to look at that affects science experiments is something that is known as bias. And bias is something that is a prejudice either for or against. So a bias is a prejudice for or against a person, or even a place, or even an idea, or an outcome, or anything else. It's just that somebody, even before knowing any of the details, they're either for or against something just based on their own personal beliefs. So for an example, if I went to Detroit, Michigan, and I asked people, what's the best football team in the NFL? Those people are probably going to be biased because their hometown team is the Detroit Lions. So I can't really trust what they have to say. Same thing as if I went up and I asked somebody who maybe is a Denver Broncos fan. Let's say the Denver Broncos are in the Super Bowl and they're getting ready to play, and I asked a Denver Broncos fan, who's going to win the Super Bowl? Well, they have a prejudice for the Denver Broncos, so they're going to tell me why they believe the Broncos are going to win the Super Bowl. But that's actually a prejudice because they already beforehand are for the Denver Broncos before the game even starts. So they're not really looking at the true facts. They're just telling you what they believe. But this happens in a lot of different instances in a lot of different cases. Sometimes we have a bias towards people that look like us. So if we see someone that looks like us, we believe that they're going to act like we would. So therefore we think that we know what's going to happen in an experiment. So we just expect something to happen because sometimes we have a prejudice and we don't even know that we have a prejudice. So if there is a bias, if a scientist is biased, that means that it's actually going to decrease the reliability because you really just can't really trust them. So if a scientist is biased, then it decreases the reliability. So let's say that we have someone who's like, hey, I made the best dog food. This dog food is better than any other dog food. And you take it home and you do a little sample. And this is dog food A, but you've been giving them dog food Z. And maybe you put dog food A in a bowl and dog food Z in a bowl, and your dog eats both of them the same. Well, this person who is trying to sell dog food A for money is going to tell you it's really, really, really good. But when you actually test it and you give it to your dog eats both of them the same. Well, what's really happening here is the reason that the scientists said that dog food A is better is because they're going to make some money. So therefore, they're biased about dog food A because they know that if you choose A, they're going to end up making money. So that's what bias is, and I hope that that makes sense. So these three things are things that can affect the reliability of a science experiment. So you're always going to want to keep this in the back of your mind as science experiments happen. You're going to think, am I being biased right now? You're going to think, do I have a control group to prove that the thing I'm changing is actually making the difference? And you want to think, do we have enough trials to have a good sample size to increase our reliability? These are the considerations that we want to keep in mind so that we can increase the reliability of our data in a science experiment, and it will help us have better results and better conclusions. That's all for now, and I'll catch you on the next video.